I couldn't have orchestrated that any better. So I'm curious, any of you cold out there? Any hands? Few people? I guess the sissy here is not that smart. The other question I have is, did any of you take a cab from the airport in the last 24 or 36 hours? How many of you had a discussion with the cabbie about how smart the smart city here of Dublin is? Anybody? Okay, I had that discussion yesterday. And coming here on the cab, he proceeded to tell me how the roads department a year ago decided to dig up all the roads in the area so that nobody could get into the Web Summit. And the year before that, they didn't plan on the internet connectivity, so there's no internet in the area. And the year before that, and the year before that, and what does all that tell you? What that tells you is that you have one part of the government and the corporate world who's doing Web Summit not talking to each other. It also tells you that the roads department doesn't ever talk to the economic development team. So you have a gap there. You have a gap in communication. And if we're going to have smart cities, we have to narrow those gaps. We have to eliminate the idea that every piece of the infrastructure in a city is in a silo all by itself. Because that's what ultimately creates a smart city, is for all that data and all that information to flow seamlessly between each other. The roads department should have known the biggest event of the year was occurring. The water department should have known the biggest event of the year is occurring. They should have been able to adjust the traffic controls so people can get in and out of this area more rapidly, given the flow in the morning and the flow out in the afternoon. But in order for all that to happen, the data has to be organized in a way that allows you to get that single view of the city and an electronic view so you can alter the way people operate on a day-to-day business. So what are some of the challenges, though, if you start dealing with this? Well, security. The idea that says we now control cities electronically, a little concerning from a security perspective, knowing that people can still hack machines, they can still get into infrastructure, they can still break in. We don't live in a completely secure world. You have old infrastructure, the lighting system, the power grid, everything else, lots of old technology. If you go into the utility industry, an industry I worked in, my last company was called E-Meter. We were acquired by Siemens. And you look at the utility infrastructure, it is ancient. It's ancient, it's old, it's proprietary, and even as it modernizes, some of it's old, some of it's new, I have that broad spectrum of data and information that's flowing between those. And most of the data that we're talking about is pretty proprietary. The data was never designed to intercommunicate with the data from the other systems. So if we go back to the traffic controls, talking to the, dealing with the weather, dealing with the city governments, all of that data, it's all in silos, really never designed to talk with each other. So we've got that challenge. Let me drill down just to give you a flavor of just one single dimension of a smart city, and that begins with a smart grid. So smart grid being our power, our water, our gas. And many of you, how many of you, by the way, wherever you live, have smart meters? So probably about half the room. So that means half of you don't even have the technology at the endpoint to allow advanced communications and to allow a smart grid. For those of you that do, what I can tell you is there's lots of manufacturers, there's lots of metering companies, E-Meter, Itron, Oracle. They all have different software formats to deal with the billing and the information flow. So again, the data not really designed to communicate together. So let's power through just that one challenge. So first of all, the control systems. The control systems are the part of the grid that actually cause power to be distributed to a particular location, regulates the gas pressure. About 3 years ago in the San Francisco Bay Area, we had a pipeline explode, massive gas line pipeline. It was a 24-inch pipeline. It blew up from 50 feet below the street, came up through the asphalt. Why did it happen? Because the control system ran the pressure up to about 400 pounds per square inch. it was designed for about 80 at the max. So imagine a massive blowtorch under the street, flaming up, incinerating about 50 houses in about 20 minutes. That's an old proprietary control system that regulated how gas flows through the pipes. I could carry that over right to the electric grid, to whatever. There are all these proprietary systems that deliver the power. The transformers don't all report information. The power grid itself doesn't all report information. So we're trying to modernize it, but we're in a very mixed mode today. The metering infrastructure I mentioned, all different brands of metering infrastructure. There's multiple vendors that do the hardware, multiple different vendors that do the software, and even if you want to be common and on one particular technology, almost impossible. You really can't do it. And so what do we end up with? We end up with data in silos. I have metering system A, that was one set of data, different than metering system B, and different than metering system C. Everybody's data format is totally different. So the problem itself, though, it's multidimensional. If I look, the trains, buses, and plane system, the train stations, the bus stations, the airports, if I go on down, go hit weather, hit the traffic systems, hit the gas and utility distribution system, ask yourself the question, were these ever designed to actually work together? I'd argue they weren't. One of our big projects that we did in the States is the FAA's Emergency Operation Network. We had to bring airport data, airline data from multiple different airports around the globe, multiple different airline management systems. We had to bring it together, and then we had to deal with weather data. There's no standard format in the world for weather data, yet we needed to bring in data from all parts of the world. Why did we do that? To give the FAA an Emergency Operations Network, the ability to overlay, FAA, by the way, Federal Aviation Administration in the US, to be able to overlay the weather data over the airport and airlines so we can find out simple things like a big hurricane's coming through, how many flights do we need to cancel, which flights are affected, and oh, by the way, which planes do I need to move out of the area? Because as an example, Hurricane Sandy a couple of years ago in New York, very destructive hurricane. You wanted to get the planes out of that area knowing they'd be damaged on the ground. So that was kind of trying to build a smart airline. That was just 3 forms of data. Now if I go on to smart cities, I have that same problem for the train system, the bus system, the airport systems, the highway systems. I can go on and on and on. Every piece of the infrastructure, if we're going to have truly smart cities, all of that infrastructure eventually has to integrate together. I need to know which bus stop I want to go to in the morning based on the weather. Is there a cover? Is it an open one? Is it next to the biggest puddle in the road? It's going to splash me every time I stand on the curb. Happens all the time. So what do we need to do? We need to integrate all this different data, again, that was never designed to be together. We have to bring all that together. So the challenge is not only this staggering growth of data, there's a massive amount of data. And it's coming all the way back from the mainframe. It's coming from the relational era. And it's coming from the newer era of technologies, even including things like social media data. So it's really about all the data, the volumes, the variety, the structure, the speed, but probably more importantly, and the more difficult problem that corporations and cities are facing trying to deal with this is it's any silo. Because ultimately, each one of these pieces of the smart city infrastructure, they have their data stored and managed in its own individual silo. It sits in its own product in probably any variety of 40 or 50 different databases. And that's just by branded databases. Now multiply that by 40 or 50 different structures of data, and I have a massive data silo problem. And so what we have to do is we have to change our relationship with the data. We have to start facing up to these silos, stop thinking about the data as this uniformed, all the data is in a single spot, and start thinking about the notion The data is highly distributed in many, many different systems and many, many different formats. And so one of the things that you have to do is you have to think about the fact that traditional relational databases, they're not designed for today's data silos. They were never designed for that. Relational databases, they make you have a schema, a common standard, a standard format. Every time you add data to it, you restructure the database. Every time you want to ask the database a question, you rewrite your SQL and you re-index it. Imagine if Google had to re-index the web every time any one of your websites change. Make it pretty hard for them to keep up. Imagine every time you typed on your screen a query in Google, and in that query, behind the scenes, some Google DBA had to rewrite the SQL and re-index the database to answer that question. It wouldn't work. So what we've done is we're starting to deal with this endless cycle of data normalization. It's costing millions of dollars and taking years and years to deal with. So a more modern approach is switch to a new type of database technology. Choose an enterprise NoSQL database for the smart city. Now I use a Google-like methodology for my database. As data comes in from all these different systems, I essentially index the data, I make it immediately searchable, and I give the same flexibility that Google does. Difference is we store the data. Why do we do that? Because I can deal with the structured components, the unstructured components. More importantly, I can bring the data from all the different silos together, and once it's together, I can make it searchable. So now all of a sudden, projects that used to take years take months, and now I can get an integrated single view of that data because I'm indexing it in, making it searchable. I'm not making you predetermine a format because predetermining a common format in the smart grid against all those data sources is virtually impossible. Smart cities do require smart data. The reason we focused in our company strategy on the enterprise side of NoSQL is we believe data has to be secure, it has to be reliable, it has to be highly available. One of the projects that we run in our company is we're the back end of Obamacare. In the States, biggest healthcare marketplace. Think of it as Amazon.com for health insurance. We see open enrollment just started a couple days ago. We're talking 50,000 concurrent users and 100,000+ transactions a second going through the system. If you're dealing with that kind of speed and that kind of momentum, you have to have a mission-critical environment. And smart grids take that to an even bigger dimension. So smart grids are going to need to think about it differently, but very importantly, as you're thinking about it differently and you're thinking about new generation of technologies to build your smart city, you have to worry about the enterprise capabilities. You can't pick up the enterprise and go, well, I'll set that aside. Imagine a smart city that's exposed to a hacker. Imagine a smart city where somebody could take over control of the bus system, take control of the water system, take care of the control of the electronic grid. Not really good idea. So you do need to pay attention to the security, the protection of the data, the availability of the data. The other thing on the availability side is once all of us become dependent on it, pretty painful if it breaks down. I can tell you sitting at Heathrow Airport yesterday trying to get to Dublin, a little bit painful when you're at one gate and they decided to board the plane from a different gate. They just forgot to tell us. And then once we got to that other gate, it was up on that monitor as well. So that's just within the airline, a couple of systems not being coordinated with each other. Creates a really inconvenience to citizens. So we do have to think about that. Fairfax County, if you go to your iPhone or your Android, you can download from Fairfax County. It's a large county in Virginia, a land record system. It allows you for economic development to basically sit in a car outside of any piece of property, put in an address, and find the historical property records going all the way back to the mainframe era. So they've taken a very innovative approach for economic development is to help developers build and deliver more quickly. And lastly, smart cities require smart data. So a few points of encouragement for you. Acknowledge the data challenges. Don't think for a minute you're going to deliver a smart city without dealing with the data challenges. Recognize that these challenges require modern technology. You are not going to deliver this with your typical Oracle DB2 Microsoft SQL Server database. A structured relational database will not deliver on the promise of the smart grid because it can't integrate the data effectively. Smart cities are possible, and so don't get discouraged by what sounds like an overwhelming data silo challenge. It's completely possible. And lastly, if you're going to have a smart city, you're going to have smart data. Thank you very much.